Welcome back. Before we start our deep dive into today's topic, please take a second to hit that like button, subscribe to the channel, and turn on notifications so you never miss a technical breakdown. It really helps the channel grow. In the early days of computing, virtual machines were the go-to solution for running multiple applications on a single machine. But with the rise of cloud computing and microservices, the need for a more lightweight, portable solution became clear. Containers emerged as this solution. Unlike VMs, which have their own operating systems, containers share the host system's kernel, making them much lighter and faster to start. Docker popularized containerization by providing an easy-to-use platform that abstracts away the complexity of managing containers manually. So, what exactly is Docker? At its core, Docker is an open-source platform that automates the deployment of applications inside containers. It provides tools to package an application and its dependencies into a container image. These images are then run in isolated environments called containers. Docker also includes registries like Docker Hub where you can store and share these images. To understand how Docker works, let's break down its architecture. At the center is the Docker engine, which manages images, containers, networks, and storage. The engine uses a container runtime like Runc to execute containers. Images are built from layers, each representing changes made to the base OS. This layered approach reduces image size by sharing common layers across different images. The Docker workflow starts by writing a Docker file, which is a script that defines the steps to build an image. Once built, this image can be run as one or more containers. Containers are isolated, but share resources efficiently with the host system. Images can be pushed to registries like Docker Hub for sharing and pulling them later. Docker has become essential in many real-world scenarios. One of the most prominent is microservices, where each service runs in its own container. This allows services to scale independently and reduces conflicts between different parts of an application. Another key use case is continuous integration/continuous deployment, CI/CD pipelines, where Docker ensures that code changes are tested and deployed consistently across environments. Like any technology, Docker has its pros and cons. On the plus side, it ensures that applications run consistently regardless of where they're deployed. Containers are much lighter than virtual machines, making them faster to start and more resource efficient. They also fit perfectly with microservices architectures, allowing each service to operate independently without affecting others. While Docker is a powerful tool on its own, it often works alongside other technologies. Kubernetes has become the standard for orchestrating and managing containers at scale. Docker Compose allows developers to define and run multi-container applications with just a single file. Jenkins, widely used in CI/CD pipelines, integrates seamlessly with Docker to automate building, testing, and deploying applications. If you're new to Docker, it's best to start by understanding the fundamentals of containers and how they differ from traditional virtual machines. Once comfortable with that, dive into core Docker commands like build, run, push, and pull. Next, learn how to write Docker files to define your container environments. Finally, explore multi-container setups using Docker Compose to see how complex applications can be managed efficiently. In conclusion, Docker has revolutionized how we develop, deploy, and manage applications. Its containerization approach offers consistency, efficiency, and scalability that traditional methods simply can't match. I encourage you to explore Docker further and apply it to your projects. Don't forget to like this video, subscribe for more content, and comment below with any questions or thoughts. And that wraps up our explanation. If you found this useful, please hit the like button and share it with a fellow developer. Don't forget to subscribe for more technical tutorials. Thanks for watching, and I'll see you in the next one.